Welcome back to Advanced Arduino Basic Project, and today we will learning about water tank monitoring with LCD. And here is the agenda: overview, components, principle, schematic and procedure. So in this project we learn about how to monitor the water level in a tank, how a controller processes the data, and how to automatically control a water pump based on the water level. The required components are Arduino, LCD, resistor, push button, DC motor, relay, NPN transistor, ultrasonic distance sensor and red LED. The principle: the system operates on the principle of hysteresis driven non-volatile state control, which prevents mechanical wear by implementing a wide differential between the activation threshold and the deactivation limit. By utilizing time of flight acoustic to derive distance from the sonic reflectivity, the controller maps real-time fluid dynamics to a user-defined coordinate system stored in the EEPROM. So this ensures that the device maintains its operational logic and calibration constants through power cycles, transforming a simple sensor actuator loop into a resilient autonomous industrial management unit. And this is the schematic diagram. Next is the procedure. Step 1 is build the circuit. So here we are using motor, LED, transistor, this is BJT, and resistor, LCD, 4 push buttons, ultrasonic sensor, and this is the microcontroller Arduino Uno. And next is the program. So first step is the pin declaration. So here we declare the pins. We having 4 push buttons: menu button, plus button, minus button, and one more is the save button. So here we having LCD pin numbers, and this is the motor pin declaration. And this is, here you can see tank size. So it reads tank size from the EEPROM. EEPROM means it is permanent memory, so it remembers your settings even after a power outage. And this is the void functions. And in the setup function you can see it configures the button as a inputs. So these are the input buttons, and motor pin as an output. So it also consider these are high. It also starts the LCD and shows a water management system as a welcome message. Here you can see LCD will print water management. Long read ultrasonic distance of trigger pin and echo pin. So the read ultrasonic distance function handles the eyes of the system. So it sends 10 microsecond high pulse to the sensor trigger pin, and here we using the pulsing function to see how long the sound takes to bounce back. And next is the loop. So here you can see centimeter, that is converted into inches. So the time is converted to centimeters, then to inches, and finally to feet. So serial print line is print in the serial monitor. So it calculates the water level. Here you can see it calculates the water level by comparing the measured distance to the saved tank size. So here you can see we calculate the water level by using the tank size and measured distance. If the sensor sees 0 feet of empty space, so then it is 100%. 100% full. So this acts as a automatic motor control. The most practical part of the code is the automatic pump logic inside this loop. So here you can see if the water level is below 20%, then the motor pin is high to turn the pump on. Once the water level reaches 100%, to shut the pump off and prevent the overflow. So this also acts as a menu system. So how means the code allows to change the tank depth without rewriting the code. So here we using 4 push buttons. So pressing the menu button switches the page variable between the home screen and menu screen. While in the menu, the plus button and minus button we use it. Why? Because to increase or decrease the tank size value. Pressing the save button writes the new size into EEPROM so the system stays calibrated. So that's why we use it 4 push buttons. So that's all about the code. Let's do the circuit. The required components are Arduino, LCD, motor, BJT, NPN transistor. So first thing is placing the components. So Arduino, then ultrasonic sensor. This is the sensor. Rotate this, and next we need push button. So push button is here. 4 push button is required. This is for menu and plus button and minus button, and this is the save button. And we also need DC motor and LED, then relay. Here we using relay SPDT, then transistor and breadboard. So I am taking small breadboard. Then transistor is required, so this one NPN transistor, and one resistor, such resistor. So 220 ohm resistor is required. Change it as ohm. So one thing we forgot, that is LCD. Sorry, search it here, LCD. So I am taking LCD 16:2. So now, let's place this here and relay pin, and this is motor and LED. So we need to place LCD now. Keep this little above. Here place the LCD. and relay, then DC motor and this LED. Yeah, placing is done. Now first we do the LCD connections. So this LCD ground is, this should be connected to the ground, negative rail. So here I am changing color as black, and this is plus positive rail. Before that, this is the V-out connection. So now we need to connect the RS. So I am connecting this to the pin number 12 of the Arduino. So this is pin number 12. Or you can, so I am connecting it here, or you can connect it here also. Yeah, so this R5 is resistor selector. So this is RS. I will connect this to here, or you can change like this. Yeah, make it straight and change the color if you want. Yeah, RS is done. Next is the enable pin. So I am connecting it to, let's see, this is RW, right? So yeah, RW should connect it to the ground. So this is RW, sorry, enable pin. So this I will connect to the ground. So enable pin should be connected to the D11. So here we having DB4, so then DB5, DB6. So all these pins should be connected to the Arduino. So now enable pin connection is left, right? Yeah, so this enable pin I will connect it to the pin number 11. So pin number 11 is here. Yeah, connection is over. Change the color as yellow. Then this is done. Here also you need to change the color. If you want, you can change. Then DB4, I will connect this to the pin number 5. Yeah, here. So I will change the color to green. Do one thing. Connect to this. and next is the DB5. So I will connect this to the pin number 4 and change the color if you want. Next DB6 pin number 3, this is DB6 here you need little increase. So change the color. So I am changing this to the color blue. Next is the DB7. So I will connect this to pin number 2. I will change the color to the purple. This connection is over. Now LED connection is left. So I am using 220 ohm resistor. I will connect this to the positive rail. So this pin to the LED anode and this pin connects to the negative rail. I am changing color to black. So now we need to short these two ground pin to the ground pin. So this is plus positive rail to positive rail. Now these pins are shorted and we need to connect ground and power pin to one of this. So I am connecting here. So this is negative rail, right? So this is ground pin. I am connecting this to the negative rail and this 5 volt should be connected to the positive rail. So just connect this to here. So this is the positive rail. I am changing color to red. So this LCD connection is over now. Now we need to connect this part. So the anode pin of LED is connected to this terminal. So make it straight. So I'll change this color to black. And this relay pin should be connected to the emitter. So here, little down. This connection is done. So this cathode pin, I will connect this to the motor, and this motor pin is connected to this terminal, and this is connected to the negative rail. So here I am taking this and connecting to the relay terminal. So this connection is over, and this terminal of motor is connected to the relay. So yeah, this. So I am changing the color. And this terminal should be connected to the positive rail. So here I am using this this relay connection over this one, and this here it is over. Now this base is connected to this analog pin A5. So this is the analog pin. So I am connecting here. So I am changing the color to pink, and this collector pin I will connect this to positive rail and change the color to red. So this part is done, right? So now we need to connect the ultrasonic sensor and push button. So this terminal I am connecting this to the another terminal of push button. So here I am changing the color to black. So now this one should be connected to the another terminal of push button. Similarly, before that so this one connected to the next terminal of the push button. So this is over, and one of the terminal, so take this terminal, should be connected to the ground pin of the ultrasonic sensor, and this ground pin should be connected to the ground. So here I am taking this ground and I will connect. And this is 5 volt, so we need to connect this to the power pin. So this is power pin, right? I'll change the color to red. Then ultrasonic pin should be connected to the pin number 7. So here this is pin number 7. I am directly connecting this. This connection is over. Now we need to connect this push button pins. So this pin I will connect this pin to the A4 analog pin. I am changing the color to grey. So this pin to digital pin number 9. And this pin to pin number 8. I'll change it to yellow. And this pin I will connect this to the pin number 6. So this is pin number 6. Yeah, this part is over. All connections are done. Now we need to write the code. So here I am using text. Continue. So start simulation. Invalid header file. Sorry. Start simulation. Yeah, this is the welcome message, water management system. Now please set the tank size from menu. So this is menu button. So this is increase button and decrease button. Now we need to increase the feet, 8 feet. Now save it. Now tank level is 62%. Here you can observe the speed of motor. Yeah, 62. So now again press tank size, increase, negative button, this is plus button, save. Here you can see the speed of motor and this LED showing. So this maximum current is flowing, it indicates, right? So maximum is 20 milliamps. It having more than that, so it's showing like this. So let's set the value of tank size, save it. Now you can see 70%. Now you should observe this. Yeah. Now you can change the tank level. You should observe the speed of motor also. So now bulb is not glowing and motor speed is 0 RPM. Little increase it, tank level. See now motor speed. The water management system works by automatically monitoring water depth and controlling a pump to maintain the tank level. So this is what monitoring. The system uses an ultrasonic sensor to bounce sound waves off the water surface. By measuring how long the echo takes to return, the Arduino calculates the distance and converts it into a percentage based on the tank size you set. So here what happens, the decision making. The brain follows two simple rules to keep the tank filled. One is refill and one is stop. I already explained this in code. So if the level drops below 20%, the motor runs on. Once the level reaches 100%, the motor turns off to prevent overflow. The LCD displays the current percentage. So here you can see the level at a glance. So this motor, it is controlled by a relay. So does the physical work of the pumping of water. And this is the indicator, and LED lights up whenever the pump is active, giving you a quick visual status of the system. So we can change the tank size up to 10 feet by using these push buttons. So this value is saved in the EEPROM, meaning the system remembers your settings even if the power is cut. So that's all about the water tank monitoring with LCD. For more project, please watch the upcoming videos. Thank you all.